Another application which we look into detail now quickly is the street surveying application. For example, surveying the streets for TomTom, where pictures are taken, where positions are taken, and where maybe road conditions are taken. Or, which is similar, inspecting the roads in detail and inspecting damages with these sensors like you see here. The architecture could consist of different parts, and the architecture is kind of different from the centralized architecture in the toll gate scenario, because you somehow do a pre-processing and you somehow access data for working with the data from other parts of the application. So let's have a look at the data acquisition process first. On the left side you see the survey vehicle, and the survey vehicle is equipped with sensors, with positioning devices, and they work together with a specialized logic to acquire all the data and to store the acquired data in a local storage first. And as you can see here, there are different instances of these survey vehicles, so different vehicles doing the work for the street surveying. The amount of data is quite large, the amount of data which is acquired here, and that's why it makes sense to store the data first in the vehicle, and when the network is available, for example when the vehicle is in the depot, then the data are synchronized via this interface into the centralized application. And the centralized application here consists of two parts mainly. The first part is this preparation phase where you can do data cleansing, for example, and the other part is the part for the storage, for storing the street surveying data. And if the data arrive from the street surveying vehicle, then first you have to import the data in a, let's say, specialized data importer. He connects to different sensor data, maybe to specialized files, output from the sensors, and brings every data item into one central schema. And if you have this data imported, then you might process it in two ways. First way might be an automatic data cleansing. Data cleansing means that you somehow want to filter out outliers. Some outliers you can detect automatically. Some other outliers, which might require manual interaction for detection, require manual data cleansing, such that an operator somehow interacts with the data cleansing algorithm and decides what data to use and what data to filter out. And both of these components, the automatic data cleansing algorithm and the manual data cleansing algorithm, interact with the central storage. The central storage for writing the data to the central storage, and occasionally also reading from the central storage to maybe evaluate the data or help evaluating the data appropriately. And starting from the central storage, if data are stored there, then some backup jobs work for pulling a backup, that you assure proper operation even if the central storage fails, that you don't lose all the survey data when, for example, a hard disk fails. And one additional component might be a user device here. A user device maybe containing an app for data browsing when a specialist on the road, for example, wants to determine a damage, maybe wants to put in additional information for a damage, for documenting, for example. Then the user interacts via an app with a central storage. And on the other side, there's the interaction of the user. Here, somehow simplified, the user interface is not mentioned here in detail. Again, there might be different users out there, different specialists evaluating the road in detail, and therefore we have this replication of the user devices with their regarding apps.